Hi everybody, thanks for watching another math video. In this video, what I would like to do is introduce the concept of geometric similarity to you. We'll mostly be talking about triangles, but many of these ideas are true for other kinds of figures as well. I'm going to introduce a couple of really important terms that we use all the time when we're talking about solving problems with similar figures. All right? So let's have a look here. In math class, when we say that two figures are similar, it means something very, very specific. It means that those two figures are the same shape, but not necessarily the same size. They might be the same size, in fact, but they don't have to be the same size. But if two figures are similar, it means they are the same shape. Well, actually, this means a couple of more very important things. First one is that if they are the same shape, that means that you can take their corresponding angles, and I'll describe what corresponding means here pretty soon, but you can match up their corresponding angles, and those will be congruent pairs of angles. So the corresponding pairs of angles are congruent to each other. All right, that's a very important fact about two similar figures. And another important fact is that if two figures are similar, then that means their corresponding sides are proportional. And I'm going to explain in this video basically what it means for sides or angles to be corresponding, and we'll focus a lot on what the word proportional means here. Okay, so I'm really glad that you're watching. First, so corresponding angles, corresponding sides, that'll be the main focus of this video, what that means. All right, so first let's talk about just corresponding in general. In general, corresponding means, could mean matching, or maybe said a different way, in the same relative position. Okay, so let's talk about a couple of triangles. I've drawn a couple of triangles here, triangle CAT and triangle DOG, and I'm saying right off the bat that they are similar triangles. And furthermore, I'm going to say that angle C and angle D are congruent to each other. So that means that you know that angle C and angle D are a corresponding pair of angles. They have the same measure. They are congruent to each other. And that's true for other pairs of angles too. Angle A and angle O, those are congruent and corresponding, and angles T and G are congruent and corresponding. All right. Now, it doesn't really matter the orientation of the figure. These two triangles are in basically about the same orientation. All right. But if I took the triangle DOJ and rotated it around, it would still be the case that angle D and angle C are corresponding to each other because they are the same measure. So the word corresponding means relative to the other parts of the triangle. It doesn't mean necessarily in the same orientation. Okay? So, that's one perhaps tricky part about the word corresponding. It's not about the orientation of the triangle, it's about the measurements of the parts. All right? So what we're going to say is that triangle CAT is similar to triangle DOG. This right here, everybody, is called the similarity statement. That little statement right there with the symbol for triangle, the letter CAT, the symbol for similar, and then triangle DOG, that is called the similarity statement. And it actually contains a lot of information beyond the simple statement that the triangles are similar to each other. It's also saying, by the order of the letters, which angles are corresponding. So when you see CAT and DOG, that means that angle C corresponds with angle D, angle A corresponds with angle O, and angle T corresponds with angle G. All right, so there's a lot of information provided in that similarity statement. In fact, there's even a little bit more, because it's also saying that the side CA is corresponding to the side DO, the first two letters in each of those triangles. Okay, so those are corresponding sides, and AT and OG are corresponding, and CT and DG are corresponding pairs of sides. Okay, so that similarity statement has a lot of information packed into it. It's very important that you observe that the letters have to be in the correct order. For example, if I wrote the statement triangle ATC is similar to triangle GDO, you would know that I'm talking about those triangles there, but that statement is actually wrong because it does not match up the corresponding parts in the right order. Okay? So, corresponding is a big deal here when we're talking about similar figures. Now let's talk about the word proportional. And the word proportional, I think, is also kind of a heavy word. I would like you to think of the phrase equal ratios when you see the word proportional. So in this slide here, I'm going to review something that you may have learned already last year, and that is how to do a dilation. Hopefully you remember that doing a dilation of one figure to get another figure gives you a new figure that is similar to the first figure that we started with. So this is another way to guarantee that we've got similar figures. So I'm going to set up a triangle there, PBJ, and I've got a point outside the triangle there, point A, that I'm going to use for my point of dilation. Now, in case it's been a while since you have done this, this is how we do a dilation. I'm going to take advantage of the little grid squares here on the background, and I'm going to locate the first point of my triangle. I'm going to use a scale factor of 3 by drawing a line from A through P to my new point. And that line that I'm drawing is 3 times as long as the distance from A to P. So if I call that distance from A to P like unit 1, or just a single unit there, I triple that distance to get my new point P prime. Now I'm going to do that for the other 2 points too. Now I don't really know how long it is from A to J exactly, but I do know that to go from A to J, I go up 3 and over 7. So I'm just going to do that 2 more times and continue that line from A through J to locate my new point J prime. So that's the second point on my triangle. And I'm going to do that one more time from A to B. Okay, I just kind of repeat that same slope from A to the point on the triangle. I'd keep on drawing that line, and I've got now my 3 points of the triangle, so I can draw my new similar triangle. And I can say that triangle PBJ is similar to triangle P prime, B prime, J prime. Now let me clean up the drawing a little bit. Mark off my congruent angles there. So yeah, all my corresponding angles are congruent to each other. And so let's talk about what it means for sides to be proportional. That is dealing with the lengths of the sides, okay? So if I measure the length from J to B, I get 4 squares, and from J prime to B prime, I get 12 squares, just by counting the squares, okay? So now let's measure the other sides of the triangle too. Side PJ is 5, and side P prime J prime is 15. And by the way, I got that by just setting up a couple of simple right triangles and using the Pythagorean theorem to figure out how long those sides are. All right, so the Pythagorean theorem is very helpful here to get those lengths. In fact, that's what I used to get the other sides. Don't worry about this if this is confusing, but from P to B is the square root of 17, and from P prime to B prime on the big triangle, it's the square root of 153, which, using a little number trick, simplifies down to 3 times the square root of 17. So there's all my measurements, and now what it means to have equal ratios is this, that if I set up a fraction of corresponding sides, like 12 over 4, and I simplify that fraction, I get 3, all right? That ratio equals 3, and that is, no coincidence, the same as the scale factor. And in fact, every other pair of corresponding sides simplifies down to the same ratio of 3. All right, so there's a sentence here that I'm going to write, and it's very important. I hope you take a moment to maybe stop the video and copy this sentence down. It's really important. The ratios of corresponding sides are equal. It's really about the simplest and most direct way to say this mathematical truth here about these sides being proportional. The ratios of corresponding sides are always equal for similar figures. Okay? All right, so let's summarize here what we've been talking about in this little video. Similar triangles, or actually any kind of polygon, but let's stick with triangles for a moment. We use the word corresponding a lot when we talk about similar figures, and I want you to think of the word matching if you're not yet totally familiar with the word corresponding. So matching or same position is a good way to think of the word corresponding. And one thing that we can say is that in similar triangles, the corresponding angles are congruent. Okay, so the matching pairs have the same measure, another way to say that. And also, corresponding sides are proportional. All right, so we use that word corresponding a lot, we use the word proportional a lot, and once again, the ratios of corresponding sides are equal, and that's a really important idea about similar triangles. Okay, that should do it for this video. Thanks so much for watching. I hope you're doing well, and I hope to see you real soon. Bye-bye.